Okay, what we're looking at from a producer standpoint with average product is for each input that I put in, so whether it's a person that's working, whether it's a piece of wood to make the desk, for each input that I put in, how many pieces of output am I getting? Okay, and that's an important number because when you are producing, you don't want to put in so many inputs that you don't get anything out for it. Okay, so all we're going to take is the units of output, which is whatever we're creating. Okay, outputs is always what you're making, and divide it by the units of input, so anything that goes into it. So simple division problem there, but you gotta make sure you have your outputs over your inputs. Sometimes you're gonna have to add inputs before you can divide. Okay, so we have 3 workers and 3 machines. Our inputs would be 6. Okay, so keep that in mind when it comes to average product. Now we have marginal product. All right, this is the last one kind of the formulas. So the marginal product is going to be the change in output divided by the change of inputs. So what we're looking at with marginal product is when I do decide to change and put in 5 more workers, how many more products am I getting out? Okay, because there's going to be a point, guys, where you can add in workers. Okay, say, okay, I add in a worker, I get out additional chocolate bunnies. Okay, but when I ask Mr. Hummel's class to come in from next door and we bring in 30 more people, okay, we're actually going to start losing the product that we make because you guys are going to start fighting for resources and be messing around with each other and whatnot. So there will be a point where you add in too many inputs and your total product's actually going to go down. So that's what marginal product is looking at, is for each additional, remember marginal always means extra, so for each additional input that you put in, how many outputs are you getting out? Okay, so what you have here are just some simple addition and division problems, really. Okay, so now we're going to take some time, turn this off, and we're going to go through some examples of these. Alright, so first formula we started with was what? Price elasticity of supply. Alright, we've got 2 different ways we can go about that one. Alright, so remember, we could have quantity supplied changes, let's say 17%, and price changes 32%. Okay, so price elasticity tells us that it is change of quantity supplied divided by change of price, right? So for this one, our quantity supplied is 17, price is 32, so we end up with 17 divided by 32, which is 0.53, which makes this what type of supply? Inelastic, because it's less than 1. Okay, let's not forget though about the second type of elasticity problem where you don't have percentages there for you. So quantity supplied goes from, let's say, 90 to 72. Price is going to go up or down? Down. Remember, law of supply says that as price goes up, quantity supplied goes up, price goes down, quantity supplied goes down. So quantity supplied went down, so we're going to go from 15 to, let's say,
8.
All right, 8. Very good. Okay, now remember, we don't have percentages, but we need them in percent form first. So our first step is to find the percent change of quantity supplied. What do I got to take? New minus old divided by old. Good. So how do I set it up? 72 minus 90 divided by 90. Remember, we're going to drop negative signs. And that's going to give me 20%. Now we have to find the percent change of price. How do I set that one up? 8 minus 15 divided by 15. Again, drop negative signs. That's just telling us that it's decreasing. And we get 47%. But we're not done, because we still need to go into the price elasticity formula. So price elasticity equals what over what? 20 over 47, very good. And we get 0.43, making this product an elastic supply. Okay, so there are your two types of elasticity problems, which I will leave up here for you. Okay, now our next formula was what? Total product. Okay, remember total product. All we're doing is adding. So let's say January, we make 400 of our product. February, we make 275. March, we make 580. So for a 3-month period of time, we want to know what the total product is. So if we're going to add, we're just going to add all those together. 400 plus 275 plus 580, 1,255 is going to be the total product for that production. So that's as hard as total product is. Okay, average product is next, right? Yes? Okay. Okay, average product tells us that we have to take outputs divided by inputs, right? So let's say that we are making, well, we'll make our chocolate bunnies. And we make 972 chocolate bunnies. Okay? And our inputs, including all of our factors of production, are going to be 39. Okay, so average product, we're just going to take our outputs that we made, 972, and divide them by our inputs, 39. And we're going to get 24.9. Okay, so again, what this number is telling us is that for each one of the inputs that we have making the product, we're getting out just about 25 units of output per unit of input. So that's what average product is telling us. Now, the last one is marginal product. Okay, marginal product tells us it's the change of outputs over the change of inputs. So let's say our outputs are still our chocolate bunnies, and our outputs are going to go from 972 down to 774. And our inputs, let's say, go from 500 to 337. Okay, now, big point here, guys, and this is something that messes people up year after year. This is not percent of change. So there is no new minus old divided by old needed for marginal product. It is just simply the change between two numbers. So our change of outputs, we're going to take 972 minus 774, and that's going to be 198, which is our change of outputs, divided by our change of inputs, which is 500 minus 337, which is 163. So then we divide those out, and we get 1.21. So again, this basically is telling us, and here we lost inputs, so this is telling us that for every input that we took out, we lost 1.2, essentially, units of output for every input that we took out. Okay, so any questions right now on any of those formulas or any of those math problems? Okay, then what I want you to do right now is take out a piece of paper. And real quickly, I want you to write yourselves a math problem for each one of these scenarios. So I want you to write an elasticity problem. Okay, I want you to write a total product math problem. I want you to write an average product math problem and a marginal product math problem. Okay, so for instance, guys, if you're looking at average product, okay, the things that I have given to you orally here is all you have to really write down. Okay, so you just write down average product. Okay, my outputs changed. You know, my outputs were this, my inputs were this. That's really all you have to do for a math problem. Okay, so write yourselves a math problem for each one of those scenarios. Don't forget price elasticity. You don't necessarily have to solve the problem right now, guys. Just go ahead and write the problem. Hello, it's Brianne. Hi. Mm-hmm. I can't at the moment. But just go ahead if you need to, just send one of them out in the hallway, and I'll take care of it. I'm just right now. So, okay, bye. Okay, how many are done with your problems? Okay. If you are done with your problems, I want you to now pick a partner and get with your partner, and with that partner, okay, you are to take them through your math problem and how you would now go about solving your math problem. So actually teach them how you would finish your math problem. So go ahead and partner up real fast. Take somebody through your math problems and teach them how to do it. If you need a group of 3, guys, because we have so many people making up tests, go ahead and get in groups of 3. If you just got back from taking a test, you can write down the examples on the board. You're not exchanging, guys. You're teaching each other how to do your problem.